Okay, so here's an example. Here's another good example. Okay, so calculate the molarity of a solution prepared by dissolving 1.56 grams of gaseous HCl in enough water to make 26.8 milliliters of solution. Okay, so how do we do it? Well, we need to convert this into moles, and we need to convert this into liters, and then we divide the two results, the moles by the liters, and that gives us the molarity. Okay. So, and then the wording of this, where it says in enough water to make 26.8 mils of solution, the reason why the wording is expressed that way is because we have to consider when we measure out a volume of liquid and then we add something to it, like a solute, it could increase the volume of that liquid, right? So we have to be very careful when we're talking about the volume of our solution. Does that volume already contain the dissolved solute or does it not? And so the wording of this, in enough water to make 26.8 mils of solution, that indicates, that implies that the solute has been added. So 26.8 milliliters is the volume of our solution. Okay. So I'll start by taking the 1.56 grams of HCl, and I just want to convert that to moles, and I can do that using the molar mass. So I calculated that already. That's 36.46 grams of HCl in 1 mole. Okay, and when I do that, let's see here. I've got 1.56 divided by 36.46. Okay, and so I get with 3 significant digits, 0.0, let's call it 428 mole. Okay, and so now I've got to calculate my volume. So 26.8 mils of solution. Okay, so I know 26.8 milliliters. I want to convert it to liters. Okay, so, and I know that there's 1,000 milliliters in 1 liter. So I just moved the decimal over 3 times. So that's 0.0268 liters. And then now finally, to calculate the molarity, I'm just going to divide this by 0.0268 liters. So, and I'm going to keep, like, I estimated sig figs up here, right? But look, I'm going to keep the result in my calculator. Because since this is a multiplication and a division, I can just do the sig fig rules at the end. So I wrote 0.0428, but I'm keeping all of these digits in my calculator, okay? So I'm going to say now divide by 0.0268 equals, and now that's 1.5965, 3 significant digits. So I'm going to say that that's 1.60 molar with a big capital M. So molarity describes, or molarity is moles over liters. Molar describes the solution. So we could say that this is 1.60 molar is how I would describe it. Okay. So now here's a different type of problem. Give the concentrations of each type of ion in the following solutions. 0.5 molar cobalt, that's got to be cobalt 2 nitrate. Okay, so let's break that down. So when I'm looking at that formula, I recognize that that's got to be cobalt 2 plus, and I also recognize there's 2 NO3 minuses. If you're not comfortable with breaking apart a formula into its ions like that, need to review, okay? And so now I'll show you how I can set this up like a dimensional analysis, which is kind of the long way of doing it. But then hopefully if you get comfortable with this, you're able to just kind of do this in your head really quick. So if I say 0.5 molar cobalt 2 nitrate, okay, look at this. I know in 1 mole, let's see, how do I want to do this? Yeah, I know in 1 mole of cobalt 2 nitrate, there's 1 mole of cobalt 2 plus. Okay? So 1 divided by 1 is 1. And so that means for A, it's 0.5 molar cobalt 2 plus. Okay, now what about the nitrate though? Okay, so let's do that down here. All right. So then in 0.50 molar cobalt 2 nitrate, or really I should say in 1 mole of cobalt 2 nitrate, there's 2 moles of nitrate. So then that means that it's actually 1.0 molar nitrate. So this will be confusing for some of you based on my experience, okay? So let's just think about this, right? If I start with 0.5 moles of solid cobalt 2 nitrate, so I've got some solid chunks, I've got a powder, okay? And I put that and add enough water to make 1 liter of solution. So 0.5 moles in 1 liter. So that's 0.5 molar cobalt 2 nitrate. But now, once that dissolves, the solution is going to be 0.5 molar cobalt 2 plus and 1.0 molar nitrate, because in cobalt 2 nitrate, there's 2 nitrates for every 1 cobalt. Okay, I'm going to leave this part B for you to do on your own, but I'll just say very briefly, hopefully maybe you can see this now. In 1 molar iron 3 perchlorate, there's going to be 1 molar of iron 3 and 3 moles, 3 mole per liter, or 3 molarity perchlorate. Okay, hopefully you can see that without having to go through this dimensional analysis. If not, practice makes perfect. Okay, so let's keep moving forward.